This question is from GATE 2013 Mechanical Engineering paper, question number 43. A hinged gate of length 5 meter inclined at 30 degree with the horizontal and with water mass on its left is shown in the figure below. Density of water is 1000 kg per meter cube. The minimum mass of the gate in kg per unit width perpendicular to the plane of paper required to keep it closed is. Let's find out. In the question, we are being asked to keep the gate closed. That means there should be no net moment acting on the gate which will move it. That is why we can equate the moments due to water force and the moment due to the weight of the gate to each other, because we need summation of moment about the pivot point to be 0. And thereby we can find out the minimum mass required to keep the gate stable. So in order to take the moment, we need to have the forces and the distance of those forces from the hinge point. First thing, we'll start with marking all the distances here. So this is the figure given. This angle is 30 degree. This is the gate. So the CG will be centrally located. Its mass is uniformly distributed. We'll assume it. So this will be the weight of the gate, and this will mark as CG G. Pivot point will mark to be O. Distance of CG from the pivot point in vertical direction will be this much. Let this be HG. Now these are all the parameters for gate. Let's talk about water. So water is going to exert pressure on the gate, and we can calculate the resultant static force exerted by water, and that force will act as center of pressure. So let's assume center of pressure is here at a height of HC from the water surface. Now we are considering water surface because the hinge point is located at the water surface and we want to take the moment about the hinge point. So all the distances should also be in relative to the hinge point, and the resultant static force will be acting in this direction, which we can denote it as F. Now we need to find out HC, HG, F, and W is what will be containing the mass of the gate. So mass we have to finally find out. Let's see how we can find out HC, HG and F. To find out HC, we consider this triangle where G is one of the vertices. So the hypotenuse side here will be 2.5 meter, half of the length of the gate, and we can thereby find HG using HG equal to 2.5 sine 30 degree, because as this is 30, this will also be 30 in this triangle. 2.5 into sine 30. This comes out to be 1.25 meter. Next thing, we can find out the center of pressure. So this height of center of pressure from hinge point HC is given by Hg plus moment of inertia of the gate about its CG Ig sine square theta upon area on which the water pressure is acting, A of the gate, into Hg. Now derivation of this formula is explained in the reference video that I will mention in the end of this solution. So you can refer that for the derivation. But this is a standard formula and you should remember this in order to solve such problems. You won't have time to derive it again and again. So now let's find out the terms involved in this formula one by one. We'll find Ig, A and Hg. So area of the gate on which water pressure is acting is simply A is equal to length of the gate 5 meter into width. So width, they have asked us to find out mass per unit width. So we can take width as 1 meter. Area is simply 5 meter square. Then Hg we already found out. So we'll find out Ig also now. Ig is simply gate being rectangular. We have its BL cube by 12. B is the width. We have taken 1 meter. Length of the gate is given 5 meter. Cube of it divided by 12. This turns out to be 10.417 meter raised to 4. We have all the terms. Now we can find HC. HC is equal to 1.25 plus 10.417 into sine square 30 degree divided by 5 into 1.25. When calculated in digital calculator, this gives us 1.67 meter. Now we found out HC, HG, W simply we already know that it will be mass of the gate into acceleration due to gravity G. So mg, and m is unknown. We need to find out this force now. So F will also be mass into acceleration itself, but we have to take the mass of the water. It will simply be rho A into Hg which is density into volume into G. So density is 1000 into area is 5 meters square into Hg we already found out 1.25 meters, and we'll keep G as it is because there will be G in the other term also. So it will anyway going to get cancelled out. So F will therefore be 6250 times G Newton. Now let's take moment about the hinge point. Summation of moment about hinge point should be 0 for the gate to be stationary. This gives us F into. Now let's say this is the gate which is making an angle of 30 degree with the horizontal and it is hinged here. Pressure force is acting like this at the center of pressure. So in order to take the moment, we'll take pressure force F into this distance. How much is this distance? It is height of the center of pressure from the hinge point HC divided by sine 30, because we need to find out the hypotenuse of this triangle that is forming here. It will be F into HC by sine 30 minus moment created by weight. Weight is acting like this somewhere here, it's vertically downward. So what we can do is we can either calculate the horizontal distance and take the moment of weight into the horizontal distance, or we can calculate component of weight in this direction, in the direction of the force itself. So we can take distance of CG also along the direction of the gate. This might denote that distance. Component of weight in this direction in the dotted one, this angle being 30 degree, will be W cos 30 into this distance is simply 5 by 2, that is 2.5 meter. We already saw this. This will be equal to 0. Now let's substitute all the values and find out the answer for mass of the gate. Force is 6250 times G into HC is 1.67 meter divided by sine 30 degree. This is equal to mg, m is unknown, cos 30 degree into 2. In order to find mg, let's keep m on one side and take all the other terms on the other side. G on both sides when divided gives us 1. So what we are left with is 6250 into 1.67 divided by sine 30 into cos 30 into 2.5. This when calculated in digital calculator gives us m equal to 9641.75 kg. Let's go back and mark the correct option. So we can see the closest one is 9623. So option D is the correct one. To learn more about fluid statics and to check the derivation of the formula for height of center of pressure from fluid surface, you can refer the NPTEL video Module 6 Lecture 6 Fluid Statics Part 3 from the course Fluid Mechanics. The course is by Professor S.K. Som. He is from Department of Mechanical Engineering of IIT Kharagpur. I hope this solution will help you clear your doubt. Thank you.